Hello, my name is Randy. This is my individual project for CPSC 5200. This is the image processor service using gRPC API or gRPC, Python, and Pillow. So what does the system do? The core idea is pretty simple. The client sends one image and an ordered list of operations. The server applies them in sequence and sends the result back. So it's a very simple one input, one request, and one response. The server is also stateless, which means nothing gets stored on the server, and every request is completely self-contained. And the formats that we will be uh, accepting here are PNGs, JPEGs, and GIFs or GIFs. The architecture of the service uses 6 components. The gRPC server, which is the entry point, receives a request, orchestrates all components, and returns the response. The request validator checks everything, file size, dimensions, operation count, which in this case we are accepting 32 operations, and then the parameters of those operations that have them. The pipeline executor runs operations in order. And then the operation factory maps each operations to the correct handler functions. And the operation handlers are the isolated functions. So these are the flips, the rotates, the grayscales, all the actual image transformations. And then the image codecs are what converts the image that the client is sending to Pillow image, so that decodes and encodes so that we can make those transformations on that image. This is the C4 level 1 diagram. This is our system context. Sorry, it's a bit smushed here, but this is just showing two entities, the client and the service. The client sends image bytes and the operations list, and the service returns the result. Nothing external is involved here. There are no databases and no third-party services. For the level 2 of our C4 diagram, this is showing actual containers. So this is the actual image processing platform, and how there are separate processes communicating over HTTP. Pillow runs inside the same process as a server, not as a separate service. So this is beneficial and works because that means no extra network hops between processing steps. And then for our level 3 C4 diagram, this is a request that comes in here. The handler routes to the validator first, so it comes all the way here. And then the codec decodes the bytes into a Pillow image. So here's the validator. Is it valid? Is it valid format size? And it comes here, goes back to the gRPC handler. If there's an error, it'll stop, go back and hit the client. Or if everything is in order in those operations, we send it to the operation factory to map those operations, go to the pipeline executor, handle those transformations, and then go back to the gRPC handler, and then back to the client with the results. So why gRPC over REST? gRPC was just a natural choice. Protocol buffers handle image bytes natively. That's one, so it's good for binary payloads. I think REST would have needed a bit more. Would probably be a little less inefficient, or a little less efficient. It's a strongly typed contract, so the proto file that we wrote catches in integrations, errors, and compile times. And then the single call model was amazing. So it's just one method. So we have that one method that is just a method that we're sending to do an operation on the server. So it's one image in, one result out, and it, which is just a natural fit for our PC. And then for REST, REST is pretty resource oriented. So mainly, CRUD, dealing with databases and external databases. and that just wasn't what we were doing here for this specific service. So gRPC over REST was the way to go. Here's our API definition. So it's a single RPC method. We're just doing process image. This is the whole request here. The image will have the the actual image, the input format, the operations, and then optionally a return thumbnail. And then for the process image response, it'll return the image and the format and the optional thumbnail. For the errors that come back in gRPC, we have our gRPC status codes. We have invalid argument if the file, or if it's a bad parameter. We have resource exhausted, which is if the file is too large, because we do have a limitation on that. And then internal for anything unexpected. So every error identifies the exact operation that failed and the reason why. Yeah, and you can see all down here what those are. So for our little language, the operation pipeline is expressed as a small and simple syntax. So a plain text file is if we choose to do it that way, is one operation per line. Parameters follow the operation name. So you can see here that this is what a operation file would look like. We have the full operation, full pipeline text. So rotate degrees 45. This is the degree. Grayscale, which is one operation, doesn't take a parameter. Resize percent, which 50 would be 50%, and then thumbnail. And you can see here, the EBNF grammar defines every valid operation and its parameter rules. So you have rotate degrees operation, rotate degrees, resize percent, and the operation. Does it require a parameter? And these ones do. I also did implement a interactive terminal mode where you pick operations from the menu instead of writing a file. So I will demo that during the demo. Here we have our operations that you can see here, the parameters that it takes and what the effect of those parameters do on the image. For design patterns, 3 patterns kind of shape the design of all this. One of which is the strategy pattern. Because it's a uniform interface, the interfaces doesn't really change, and the operations are interchangeable within that interface. So adding a new operation doesn't really touch, the executor in any way. So the strategy pattern just makes sense because it's one function. It's an isolated function. The command style pipeline was another one. Naturally, because we're using an order of operations, each entry acts as an instruction or an action, and so the output of each step is determined by the one before it. So it's easy to test and it's deterministic. Factory mapping was another one. Operation factory maps operation name to the handler functions, which keeps the executor pretty clean. And there's no if-else chain, so if we add a new operation, it's just added to the factory and should just run. So here is going to be our first scenario. This is a demo of the first scenario. So here we'll do a text operation. You can see here these are the instructions that we are going to do, and our expected output is going to be rotated 45 degrees. Thumbnail is in grayscale because we have 2 thumbnail requests here. We want the very last one. We're not going to want this one. So our assumption is the last one is going to be the one we're going to keep. And the format will be preserved. So if it's a JPEG in, it's a JPEG out. And yeah, so here we go. So here is our first test. I'll show you the before picture. So here's the before picture of my friend playing the trumpet. And here is our first executable. So we'll go here. Sorry, here's the actual server on this side, and then the client on the left side. you can see here there are 5 operations that were loaded. We have rotate degrees, thumbnail, grayscale, resize percent, and thumbnail. Looks like everything went through. And here's what that full pipeline text looks like. You can see here now we have 2 new images, test result and test thumbnail. So the thumbnail should be in grayscale, which is great. And the test is also in a grayscale, but it's a bit bigger, not 300 by 300. So this is a great test. For our second scenario, this is just a single operation, very minimal request. But this time we're going to do a PNG to demonstrate that the PNG that the format is preserved, and there's no thumbnail returned because no thumbnail was added to it. We just have flip horizontal in that text file. So yeah, let's look at that. Here is the before image. Here's our test 2 image, PNG. We'll run this executable. So test2.png. And here we just have flip horizontal. So we should just see the image of that bird in France, and we should just see it flipped. Here it is here, and it's flipped. So that test worked perfectly. And then for our final test, we want to test our error case, just testing an invalid parameter and a graceful failure. Here we are going to resize by a percentage that is less than 1. So the request will fail immediately, no partial processing, of course, no errors. Errors will be identified in the exact operation and reason, and there will be no output, and the service will just terminate there. So here's our third executable. And there you go. gRPC call failed. Status code is invalid argument. Operation index 0 at resize percent. Percent must be greater than 1, and we got 0, so that's exactly what we wanted. And just to show you, just to demonstrate the terminal mode, we have the image path here. Right now I'm just instead of executing the text file, we can do an image path. So we'll do the bird. We'll select that image. Here you have 1 and 2. So we've been loading from a text file a list of operations, but we can also do it dynamically if we so choose to. So we could do flip horizontal and 6 grayscale and then 8 thumbnail. And then we can also test something else. But yeah, so here we go. So now we have a thumbnail that was created in a test 2 result. As you can see, this it did flip with the grayscale on our regular image, which is a PNG, and then also our test thumbnail, which is also a PNG. Very small, but it looks like it works. So yeah, just to wrap things up, what was built, we have our synchronous gRPC API with a contract by design. We have our 8 image operations that we implemented via Pillow, a request validator with full constraint checking, sequential pipeline executor, and a client CLI command line client with text files and interactive modes, and then 4 test scenarios, including an error case. And then what's not in it is because we're not in production, the gRPC channel isn't totally secure. So I think if this was something that we were going to go live with, or something, and we wanted to protect client's image, we would probably put it in a TLS file, or I'm sorry, TLS file, but a TLS handshake for security. We did have a 500 millisecond guideline per spec. That was not a total hard constraint because we didn't really struggle meeting that at all, and I didn't really know of a way to measure that in an effective way. We did not use cache, so each service, is independent. And because we don't have a TLS handshake, we actually also don't even have authentication if we were, wanted to go live with this. But yeah. No other big limitations. But yeah, that is my image processor. Sorry. Thanks so much, and see you soon.